All right, so let's get this final review started. So it's basically going to go piece for piece from the beginning of the semester all the way through the end, okay? So if it's not on here, it ain't going to be actually on your final exam, all right? So from here, the first question, this is coming straight out of A2, if I remember correctly, because this is all about compound inequalities. So remember, those are about ands and ors. So which compound inequality do I have right here? You got an and. How'd you know it was an and? Because it says the word and. All right. And what do you remember about and graphs? Because part of what we're going to want to know using that, getting that interval notation, the graph helps us out a lot with that. What do you remember about and graphs? Where do they shade? It's not on the outsides. It's in the middle. So ands, remember as we talked about it in class, 95% of the time they shade in here. So we hope that happens, but remember there's that 5% of the time where they do something weird and wonky, which our book liked to do a lot. So let's go ahead and start working through this. Remember, when it comes to inequalities, it's just like working two problems separately. We got problem number 1 right here, and we got problem number 2 right here. And we're just going to get both of these answers separately. So how do I solve my blue problem? What are we going to do first? We do need to get x by itself. So what are we going to do? Subtract 152. All right, minus 152, minus 152. So we've got negative 8x less than, what is 80 minus 152? Say it again. 72? No. Not exactly. 80 minus 152. Negative 72? I don't think it should be 72. Oh, it says negative 72? All right. Just kidding. So negative 72. All right. Now what do we do? Divide by what? The negative 8. Perfect. Divide by negative 8. Divide by negative 8. So x, what happens with negative 72 divided by negative 8? Goes to a positive what? 9. Now the question is, does the sign stay less than? Or is this one of those cases where it flips? It flips. You bet. It becomes a greater than. And you need to watch out for that. Because remember, in class we talked about this. Whenever we multiply or divide by a negative number, flippy flippy on that sign. Okay? And since my denominator right here is negative, that means we got to flip. We don't care what the numerator sign is. We care about dividing by a negative. Or in other words, when you look at this, like our denominator. Okay? So there's part of our answer. Now we got to go get the other part. We solve the other equation. So how do I solve this? X plus 6 less than negative 1. Minus 6. All right, so minus 6, minus 6. So x is less than negative 7. Everyone good so far? So now that we have these two pieces of information, let's take a look at what their graphs are doing, and hopefully they're going to shade in the middle because the two graphs will overlap, because that's what an and wants. An and wants to see where they overlap. Okay? So remember, I make kind of makeshift graphs because I only work with the numbers that we need to work with. What are the two numbers we need to work with? 9 and negative 7. So which number comes down here on the left line? Negative 7, because we put them in order. And then that's the 9. All right. So now we do some shading. Let's talk about 7. Negative 7, sorry. Will it be a bracket or a parenthesis at negative 7? Say it again. A bracket. No, it's not a bracket. It's got to be a parenthesis. How did we know it's going to be a parenthesis? It's not equal to on the bottom. You got it. That's right. Only if you see that line underneath this symbol like that, will it be an equal to. Okay? Will it be a bracket? So we know it's a parenthesis. Now which direction do we shade? Do we shade to the left of the -7 or to the right? To the left, because you follow the arrow. Okay? As long as your variable's on the right side, we can follow this arrow right there. So we got a parenthesis, and it shades this direction. Okay? Does that make sense so far? All right, let's look at the other guy. 9, bracket or parenthesis. Parenthesis, because again, we're not equal to over here. Do we shade to the right or to the left? To the right. Okay. So, again, remember ands want where they overlap. What they have in common. Do these two have anything in common? So then what's the answer? D and E. It does not exist. There's no overlap. D, N, E. What we were hoping for was to see this. An overlap between those. And if we did, let's talk about what that answer would be real quick. Okay? So if there is overlap, then your picture tells you exactly what to do. We've got our two numbers. We're stuck between -7 and 9, right? Is it a bracket or a parenthesis at -7? See? It's a parenthesis because you can see that parenthesis right there. Bracket or parenthesis at the 9. Parenthesis. Because again, our graph leads us right to that answer. Our graph says we're a parenthesis at -7, and we want everything between there all the way up to 9, and we're a parenthesis at that. That's why I like making the picture, because the picture, if you know what the picture looks like, you can get the answer from it real quick. Okay? So there's an and. Let's see what question number 2 is. Oh, another compound, but this time it's a what? Or. Where do ors generally shade? On the outsides. Ands usually shade in the middle 95% of the time. Ors 95% of the time. They're to the outsides. Okay? So, again, treat this just like what we did a moment ago. It's just two separate problems. So let's solve them separately. So for our red problem right here, what are we going to do? There you go. We'll get the add x by itself, so we add 7. Good, Yolanda. So -7x greater than or equal to 63 plus 7? 70s. Cool. All right. Now what? Divide by what? -7. You got to flip the sign, because again, you see right down here, because my dividing by that negative number, I got to flip that sign. So in the end of this, we get x what? Less than or equal to -10. Cool beans so far? All right. So, jumping over to the green one. What do we do to solve this one? Yeah, add 9 on both sides. Plus 9z's plus 9z's. So x is greater than or equal to, say it again, -2? I like it. So now let's take a look at what these look like. Okay? So let's get me a little graph up here. What are my two numbers I'm concerned with? -2 and -10. Which one comes first? The -10. Good. And then the -2. All right. So let's take care of the red guy. Will it be a bracket or a parenthesis at -10? Bracket this time, because we're equal to. All right. Will I shade to the right or to the left? To the left, because we can follow that arrow, and it's pointing to the left. So we got this going on right there. Cool? All right, so now we look at the other guy. our green answer. Bracket or parenthesis at -2. Bracket, right or left? To the right. Because we can follow the arrow. Does this look like what an OR generally looks like? Yeah. So if I just take these two guys and slide them down onto my line, this is the answer that we need to come up with as intervals. Okay? Because ORs, in all actuality, ANDs want where they overlap. ORs say, give me everybody. So that's why we put both of these on our line, because we want all these people invited to the party. We want all these people invited to the party. So let's talk about how we write this. So again, just start working on your number line from left to right. So we start at this arrow right here. What does this arrow mean for us? Negative infinity. Bracket or parenthesis? Parentheses, because infinities always get parentheses. And then where do we go? Up to -10, right? Bracket or parenthesis? Any questions about that piece so far? But we also want to invite these people that are over here. So we put a union between them, because we're inviting some more people. Where does this one start? -2, bracket or parenthesis? Comma, and where does it go? To infinity and beyond. There's the answer. Cool beans? I have an answer. Don't put any spaces, and make sure that you use their union symbol. Do not use a capital U. Use their union symbol, because the computer's dumb and doesn't know the difference. Okay? Use the computer's union symbol. Okay? Which means that when you're looking at that little blank space there, when you click in it, you see that yellow arrow that pops up over there. You need to click on that yellow arrow. Okay? And that will help you out. All right. And again, this one comes from section A2. All right. Jump into the next one. So this one comes from section A1. All about solving absolute values. Now, you need to be careful on this when you get to your answers, because if you look right here, it says x1 is the smaller of the two solutions. So make sure that when you fill in the blanks, I don't know if she's got any blanks on this one or not. Nope. When you fill in those blanks, make sure x1 is the smallest answer and x2 is the largest answer. And if you don't do that, if you don't put them in order, it's going to count it wrong. That's an easy way to lose points when you shouldn't. So what you'll see down here is x1 with a blank and x2 with a blank, because absolute values have those answers. Okay? So, since we have two answers, that means these really are two equations in disguise. How do we make that first equation? Nope. Nope. Say it again. Get one of the absolute values by itself. Okay? So, remember in class, for those of you that have had me, I said pick one of these absolute values to represent like your absolute value. Okay? Normally, which one did I pick? Nope. I don't know which one's the smallest. Which one did I usually pick? The left one. I let this guy be the OG. Okay? Is this absolute value by itself? Yeah, it is. There's nothing outside of that absolute value. So this absolute value is by itself. The key to absolute values is before you can write your equations, before you can do any solving, you have to make sure that your absolute value is by itself. And this one is. Everybody inside here, that x, that plus, and that 19 are stuck inside the absolute value. They're okay. It's anybody outside these absolute value signs that you need to move away. Okay? So just keep that in mind. If your absolute value is not by itself, pick anybody up outside it and move it to the other side by adding, subtracting, multiplying, dividing, whatever you need to do. Okay? But this absolute value is by itself, so that's good. We can make our two equations. So how do we make the first equation? What do we do? Nope, no zero equaling on this. Not x plus 19, not x minus 19. I like where you were going in the beginning. X plus 19 equals what? Take a guess, and it's not 0. Nope. Huh? Nope. It is staring at you in the face. 3x minus 2. When you make that first equation, all you got to do is drop the absolute value. Leave the other side alone. All I did was drop the absolute value on the left side, and I left this side alone. Okay? That's how you make the first equation. Drop it like it's hot. Leave the other side alone. Okay? Let's talk about equation 2. Usually this is the one that most of you guys will give me and get the answer to. It's equation number 2 that we tend to mess up on. So let's talk about equation number 2. What do you think equation number 2 will look like? Nope, don't switch places. All right, hold on. I like what you said. X plus 19 is still there. Equal to negative 3x plus 2. Good, there it is. Yeah. When you make the second equation, drop the absolute value again, but make the other side the opposites. So a positive 3x became a negative 3x. A negative 2 became a positive 2. Okay? That's how we make these two equations. The first equation, it's just like we drop everything. But it's got to be by itself first. Okay? Second equation, we drop the absolute value, and we make the right side all the opposite signs. Positives become negatives, negatives become positive. And now all we got to do is solve, and we got our answers. Okay? Usually, like I said, the equation number 1 is generally the easiest one that I get. Most of you get this one correct. It's equation number 2 that throws you off, because you forget to give me all the opposites. All right, let's solve. So how do I solve equation number 1? What are we going to do? There's lots of ways to solve it. All right, so move the x's over. Let's get all the x's onto one side. Who are we moving? The smallest, that's fine too. We could have moved the 3x, but you said the smallest. So Lorraine, how do I move x? Minus x, because it's really like a 1 there. How do you move a positive 1? Subtract 1. So minus 1x. So we've got 19 equal to, what's 3x minus 1x? 2x. Good. And I got a minus 2 over there. Now what? Answer. You can subtract the 19 first. Yeah. You can absolutely move the 19 first. Like I said, there's lots of ways to solve this. It's all about what you remember about how to solve and get to everything. We'll all get to the same answer no matter what. Okay, I generally like to move the x's first, because if my x's go away, then I'm already at my answer. I like to work a little bit smarter than harder. So that's why I move my variables first, because sometimes those variables will cancel out. Sometimes they don't, though. So you keep going. All right, what now? Add 2 on both sides. Yep. Continue to get that x by itself. So plus dose, plus dose. So 19 plus 2 is 21, equal to 2x. Now what? Divide by 2. And do not give decimal answers. They will want it as a fraction reduced. So 21 over 2, does that reduce? No. So one of your answers is 21 over 2. We just don't know which one yet, because I don't know what the other answer is. Any questions so far over that? All right, let's solve the other side. So what are we going to do now? All right, we can subtract x on both sides. Minus 1x, minus 1x. So we got 19 equal to negative 4x plus 2. Now what? Subtract 2 on both sides. Perfect. So 19 minus 2. 17 equal to negative 4x. Now what? Divide by negative 4. X is equal to what? Negative 17 fourths. Good. So now, hopefully, even though they are fractions, you know which one is the smaller answer. Who is x1 going to be? The negative answer. Negative 17 over 4 is our smallest. That means x2 will be the 21 over 2. So if I go up here and put my answers in, this is negative 17 over 4. This is 21 over 2. Must be in that order. Cool beans? Just remember that you're making two equations on this. Once your absolute value is by itself, to get the first equation, drop it all and solve what you see. To get the second equation, drop the absolute value, make everybody on the right side the opposites. That's why I choose the left side to be my original, because I always make the right sides the opposites. So if there was a 2 out here, I would divide by 2 on both sides. Okay? All right, now we're jumping into chapter 1. So that ends everything from chapter A that you needed to know. So this guy right here, we're writing the equation of slope-intercept. So if I remember correctly, this comes from section, I believe 1.3 or 1.4. It's one of those two. Okay? So again, keep in mind that we want to write slope-intercept, and that's what slope-intercept is. Okay? Y equals mx plus b. All right. What's the first thing you're going to have to do? The slope formula. You got to find the slope. We got to get m. We can't do anything without m. So what is the slope formula? Yes. Nice job, Logan. Yeah. Or the other formula that you could use is y1 minus y2 over x1 minus x2. It's all the same formula. So up here, I've got my 2 points. What variables make up a point? X and y. And it always goes x, then y. X, then y. How do I know which ones are the x1s, y1s versus the x2s, the y2s? Whatever you choose. But generally the 1 stands for what? The first point. The 2 stands for the second point. Okay? And I always take like the 2.5 seconds to write out who is x1, y1, x2, y2, because now I know exactly which numbers to put where. Okay? I take the 2.5 seconds to do this, and now I know exactly where each one of these numbers go in my formula. So if I look up there, who is y2? Negative 6. So my first value is negative 6 minus, because of the formula, who is y1? 11. So there's what the top looks like. Okay, who is x2? 2. Minus, because of the formula, who is x1? Negative 2. And you need to write out negative 2, because that is x1. This guy is because of the formula. This one came from the number, and you need both. Okay? Be careful of that. That's a huge mistake most algebra students make. All right. So, with that being said, what happens when you have two negatives by each other? It turns positive. Good. So that's really a plus down there. So on top, what is negative 6 minus 11? Negative 17. Good. What is 2 plus 2? 4. And of course, you should always check and make sure, can my slope reduce? Can negative 17 over 4 reduce down? No. So this is one ugly slope, but we're going to have to deal with it as such. Okay? Good thing we know how to use our calculators, because our calculators can do fractions. So we don't have to worry about doing any fractions by hand. All right, so we want to start to write that equation. What are we going to do next? I probably shouldn't have scrolled down yet. What do you want to do next? We've got our m. Okay, and then what are we going to do? So if I plug in the negative 17 over 4 in for m, I'm still missing a lot of information. I'm still missing b. Nope, no graphing necessarily. No graphing necessary. How many points do you need to write an equation? So what are you going to do? Okay. Again, let me ask that question again. How many points do you need to write an equation? How many points do I have? Pick one. You got to pick a point. It doesn't matter which one you pick, but pick one. Which one do you want to pick? Let's go with you in the orange. The negative 7, that's not a point. That's a slope. I've got 2 points up there. Pick one of those. The 2, comma, negative 6. You got to choose the whole point. So that's the guy we chose. That's the point we chose. So we've got our slope. We've got our point. Was 2, negative 6, yeah. What do we do now? Fill in my x and y. And the what? And the m. So that's one that we can do it. We can plug in what we know into our little equation right here. And we can figure out what b is and rewrite. Because remember, this guy right there is x. This guy right there is y. You have your m. So plug in. Negative 6 equals negative 17 over 4. X is 2 plus b. Solve for b. Now, this is not the way I taught you guys in class, but we can get away with this. This is fine. So, what are we going to do first? How do I get b? Yeah, we got to multiply these two. So you go into your calculator, you put in the negative 17 over 4 times 2, and you hit enter. There you go. Negative 17 over 2. That's what you should get out. When you take negative 17 over 4 times 2, you get negative 17 over 2. I am never going to work fractions by hand, so don't ask. I got a nice fancy calculator that can do all that for me right now. All right, now what? I got to know what b is. Not add 6. Add the 17 over 2. It's just like getting x by itself. Get the b by itself. How do I get rid of a negative 17 over 2? Add 17 over 2. I don't want to bring the, oops, it's supposed to be a 2. I don't want to bring the 6 over because that's bringing people to the party. I got to get everybody away from the b. So you go into your calculator, you take negative 6 plus 17 over 2. And I have no idea what that is. 5 over 2. And now all you have to do is rewrite the equation. Because you know what b is now. You know what m is. All we need to do is fill in the y equals mx plus b. So y equals, what's m? Negative 17 over 4. X, what's your b? So a positive 5 over 2. There's the equation. Okay? Yep, that's the answer they would be expecting in IMath-AS. Now, the other way that you could have done this, you already know that m was negative 17 over 4, and you chose the point to negative 6. There's another equation I told you that went along with all the information you have here. You have a point, you have a slope, you can plug into point slope. And this one, all you're going to do is distribute after you plug in the m, and then add or subtract the y1 to the other side, and you have your equation. You don't have to solve for b. So just to show you that real quick, y equals our y1 was right there. Sorry, I don't know why I put equals. So that gives us minus a negative 6, because the minus from the formula, the negative from the number, equals negative 17 over 4 x minus, here's our x1. So again, as I said, all you got to do is distribute through the parentheses. So there's your negative 17 over 4x that we had in our previous answer. You're going to notice a lot of the same numbers. When I take negative 17 over 4 times a negative 2, I get a plus 17 over 2. Negatives by a negative become a positive. How do I get rid of a positive 6? Minus 6. And that will give us the same answer that we had a moment ago. Plus 5 over 2. Notice you had a lot of the same numbers. There's that negative 6 that was in that problem. Here is the multiplying that we did between the negative 17 over 4 and the 2. It involves the same information. This is how I taught you in class how to do it. Both are valid methods. Whether you want to plug in a point to x, y, and then plug in your m and figure out what b is, and then rewrite, or whether you want to plug into point slope and then do a little manipulation. All the same, both are about the same amount of work. Okay? All right, here's that problem that I warned you about in class, where I said this is one of those big ACT, SAT problems, and it's one of our most missed problems as algebra students. Now, those of you that have not had me, I'm going to set this up a little differently than probably what you have normally seen. Okay? Because this problem, for most students, they treat it like a word problem. They're like, oh, I'm going to skip this one. I don't know what to do. But that's because you don't know where to pull all of your information from. So in here, we want to find the equation of a line passing through the point, negative 12, 8, and perpendicular to y equals 4x minus 5. Again, our equation must look like y equals mx plus b. This problem is coming from the same section that the previous problem is coming from. Okay, so I think it's like 1.3 or 1.4. It's one of those two. All right. How did I talk to you about this in class? What did I tell you to do with this? I gave you a way to organize it. Okay. It is first. And who did I call this? What did I designate that as? Well, let me ask you this. How many lines are we dealing with in this problem? 2. The one that we know and the one that we're trying to figure out. And remember in class I told you that the equation that's given to you goes under line 1. What went under line 2? The point. Because that point is for our new line that we're trying to get at. And then there was only one other piece of information that we needed. Yeah, in the middle is the relationship. And you're either parallel or perpendicular. Which one are we? Perpendicular. So that was the setup that I gave you in class. It's a way to organize the information. Under line 1 goes the equation. Under line 2 is the point. In the middle, it's all about the relationship. Are you parallel or perpendicular? All right. So, as we went through this, remember this was 3 steps. So, step number 1. What do we need from line 1? What is the only thing line 1 is good for? Finding the what? Nope. Nope. The what? Nope. No points. Say it again. M. The only thing you want from line 1 is the slope. That's why we know about the relationship. That's why the relationship is important to us. The only thing you need from line 1 is the slope. That's the first thing you need to figure out. So what is the slope of line 1? 4 over 1. Perfect. I love it. Because this is in slope-intercept. And since you're in slope-intercept, the slope is in front of the x. Whoops. That guy's our slope. And remember, slope is really 2 numbers. When you don't see the denominator, it's the number 1. All right. Now, what's step 2 going to do? Why did I need this slope in step 1? So I can change it around for the next one. So I can use my relationship here with this slope to help get our new slope. From this slope, because we're perpendicular, that's going to tell us what the slope of our line should be. What do we do with perpendicular? How does that affect the slopes? You flip it and change the sign. That's right. So I like that Habez gave us those 2 numbers because we got to flip it, which gives us what? 1 over 4. And what's the opposite sign? Negative. So our new slope is negative 1/4. Because with perpendicular, you flip it and you take the opposite sign. So the flip of 4 over 1 is 1 over 4. The opposite of a positive is a negative. And now it's pretty much all over but the crying. Step 3, we're ready to write the equation. Because notice what we have. You have a slope. You have a point. We can write the equation with that. Because that's the same amount of information we had back in this problem right here. We had the slope up here. We have a point right here. You're right back on the previous problem. So, remember I gave you two ways to do this. I don't care which way you do it. So, do we want to plug in the slope-intercept, or do you want to do point-slope? I'll take either one. Point-slope. All right. So, that means we need to plug into y minus y1 equals m parenthesis x minus x1. So, the negative 12, who is that? x1. The 8 is y1. So now you know where everything's going. So y minus, what's my y1? 8. Equals, what's my m? Negative 1/4 it is. Parenthesis x minus, what's x1? Negative 12. And you need both of those because this guy comes from the formula. This one came from the number. You need both. All right. So, all we got to do is a little bit of rearranging. So, what's negative 1/4 times x? Negative 1/4 x. What's negative 1/4? And of course, what's a negative by a negative? Positive, right? So what's negative 1/4 times 12? Negative 3. Because a negative times a positive is negative, and 1/4 times 12 is 3. And then you got y minus 8. One more step. What are we going to do now? Add 8 on both sides. Plus 8, plus 8, and now you have your equation. Y equals negative 1/4 x plus 5. And there it is. Everyone good so far? All right. Ready for the next one? Cool. All right, so this is at the end of chapter 1. This is all about domain. So how do we find the domain of a rational function? And actually, this also mixes in with what you learned about in 4.1, because you found the domain of rationals in 4.1 as well. So, how do we find the domain for the rational function? You got it. Equal the denominator to 0, do some solving. And will we like this answer that we get out? Once I know what x is in the denominator, will we like that answer? No. That's the answer we want to throw out. Because it creates a no-no number for us. It creates 0 in the denominator. And we know that we can't divide by 0 in the denominator. All right. So we'll take 12x minus 27 equal to 0. Take your denominator when it's a rational and set it equal to 0 and solve, because we got to find out who this number is, because this is the number we're throwing out. We like everybody else but whatever this answer is. So what do? Okie dokie, artichoke. So we've got 12x equal to, what's 0 plus 27? 27. All right, cool. Now what are we going to do? You got it. Divide by 12, divide by 12. And that's not going to come out to a nice answer. So that means you're going to have to reduce the fraction, because this one can reduce 9/4. Because both of these numbers can be divided by 12. But again, if you can't remember how to reduce, go into your calculator, use your alpha y equals button to make your fraction, and hit enter. So this does reduce to 9/4. So this is the number we don't like. We like everyone but this number. Okay? So we need to write up what our answer looks like. We need to put it in interval notation. Now again, remember, we like every number but that one. So where am I going to start with all my answers? We're going to start at negative infinity. And then we're going to go up to what number? We're going to go up to this guy. Because we like every number. So when I start as low as what I can go, that would be negative infinity. Okay? Because I want to invite everybody to my party but this one. So that means I start below that number at negative infinity. And I work my way up to it. Bracket or parenthesis? It's a parenthesis because we don't like it. We don't want to invite 9 over 4 to the party. That's why it's a parenthesis. We're throwing that number away. You follow me on that? If we liked it, I would have put a bracket. All right, so what do we do now? Union. What comes next? You're going to start at 9 over 4 again. Bracket or parenthesis at it? Parentheses. Yes. Yeah, it's a parenthesis. Because remember in class I said this is like we're jumping over the number. The parenthesis, union, parenthesis. It's like we're going to jump. And then from 9 over 4 over here, where do we go? To infinity. That right there represents inviting every number but 9 over 4. Okay? And that's what they're looking for. Cool beans? All right. Next one. Oh, domain again. Now it's about a radical. So in 1.5, I told you guys how we deal with this. How do we find the domain when it is a radical function? What are we going to do? It's been a while since we talked about that. Not equal to 0, but close. Not less than 0. More than, or in other words, instead of more than, we use the word greater than. Can I be 0? If I have the square root of 0, is that okay? Yeah, we can have a square root of 0. What is the square root of 0? 0. I got an answer. That's okay. So, in this, you take whatever's under here, and you set it greater than or equal to 0. Now, once I solve this, will I like these answers? Yes. These are going to be the ones that we do like. Because as long as we're 0 and above under here, we can take the square root of it. So, take the 4 plus 10x greater than or equal to 0. So what we're going to do? Minus 4. Good. Minus 4 minus 4. 10x greater than or equal to what? Negative 4. Good. Love it. Because 0 minus 4 is a negative 4. Now what? All right. Divide by 10z's. Divide by 10z's. X. Does the sign flip? No. Because we're not dividing by a negative. Our numerator's negative, that's okay. The numerator can do whatever it wants. It's when the denominator, when you're dividing, that's when you got to be careful. So no, we do not flip the sign, but negative 4 over 10 reduces. Negative 2/5. So remember, these are from negative 2/5 and above, because we're greater than, these are the numbers we like. So if the 10 was negative, I flip it. Yeah, just the denominator. You divide by a negative, flippy flippy. But when you do it from one side to the other, it's not an either or. If I divide by a negative over here, I have to divide by a negative over there. Okay? So, we need to write this answer up as intervals. So where do we start? Say it again. Nope, not negative infinity. Negative 2 over 5. You start at this number because this means greater than it. So that means I don't want to be small. I want to be large values. So you start at negative 2/5. Bracket or parenthesis? Bracket, because we're equal to. And where do I go then? To negative infinity? No. Yeah, you're not going to get smaller. You're going to get larger. That's the answer. Because we want from negative 2/5 and above. That's what this means. To be greater than or equal to means you start right here and you go on up. If it was a less than or equal to, that's when you would have began with negative infinity. If this sign ended up becoming a less than or equal to, that's when you begin with a negative infinity. Cool beans? Yeah, we're all about being big here, which is why we go to positive infinity. Okay. All right. It's an application problem, a word problem. Dun, dun, dun. It's not that bad. All they're asking you to do in this word problem is plug in and kick me out an answer. Okay? So up here it says the amount of water in a leaky bucket is given by the linear function f of t equals 2t plus 100, where f of t is the ounces and t is the time in minutes. Find the amount of water in the bucket after 8 minutes. What are we doing with the 8? Plugging it in for who? See, there you go. That's all you got to do. Plug in the t, or plug in 8 for t and tell me what the answer is. So 2 times 8 plus 100. Although that's weird why it's a plus, because it says it is a leaky bucket. So we should be losing water, but I'm not going to debate this one. That's just weird, because, yeah, that means after 8 minutes, we've gained water, and that's weird to the problem. But either way, I'm not going to argue with it, so all we got to do is just figure out what our answer is. What's 2 times 8? And 16 plus 100. So 116 ounces. Cool beans? See, not that crazy. Yeah, not that one. All good? Okay. All right, and that last problem, again, it was coming from 1.5. It's just an application problem from 1.5. So now we are starting chapter 2. This problem is coming from 2.3. Okay? It's all about elimination. Now remember, you know 3 methods. You know how to graph, you know how to do substitution, you know how to do elimination. It's supplying you the method because it's probably the best one to use on this. But you could go through and do graphing on this and use your calculator. You could go through and do substitution for this if you wanted to. It's your choice. Because for my students, I know this is at least going to be on the computer. And am I going to know which method you chose based on your answer from the computer? No. So it's your choice. But since this is about elimination, I'm going to go ahead and do elimination with it. All right. So here's what we know. For elimination, do you remember what the goal was? Before we can actually perform elimination, what did we have to make sure happened? We want to cancel something out. That is true. But how did we know if we were going to be able to cancel out? That's the goal. Say it again. If it equals to something, well, in order to cancel out, it's got to be equal to, it's got to become 0. So how did I make sure that that goal was met? What did you have to look for? Say it again. Yeah, one of these two variables, they have to have the same number in front, and they have to be opposite signs to each other. Because if you're the same number in front and one's positive, one's negative, that means they will definitely become 0. Up here, do I have a variable with the same number in front, one positive, one negative? No. So this is where you as a student, you have to make decisions. You're going to have to choose a variable. Pick one, my friend. Say it again. 4 is not a variable. Pick a variable. All right, so we're going to get rid of the y's. So that means I need to turn these y's into the same number, one positive, one negative. Well, the cool thing is I have the positive and negative, right? I just got to make them the same number. So I'm going to keep the top positive. I'm going to keep the bottom negative. I already got that. Don't change that. But I've got a 1 and a 4 here. What number can I turn them both into? Say it louder. 4. Make them both 4. That means I don't have to mess with the denominator or the bottom one. I just got to turn 1 into 4. So remember, in order to turn that into a 4, all you do is some multiplying. So what do I have to multiply 1 by to become 4? So this whole top equation we're going to multiply by 4. Okay? So what is 4 times negative 2? Negative 8x. You already know what happens with the y because 4 times 1 is 4. And what is 4 times negative 1? Negative 4. Perfect. So there's my new top equation. Do I change the bottom one again? No, because it already matches. Look, it's the same. Matches. So don't change that piece. All right. So I'm just going to write it down. Now in elimination, now that I have the goal met, right there, my goal is ready. It's ready to eliminate. What do we do now? You just add down. Okay? Which, yes, you are correct. Because if I take negative 8 plus 8, my x is now canceled. If I take 4 minus 4, we knew that would become 0, so that's gone. So what is it that I really have left over here on the left side? Nothing, which is 0. That's important to us. Hold on. No. We don't know anything yet. We got to look at the other side. What's negative 4 plus 4? 0. So, this is one of those special answers. And you have to look at the whole thing. You can't just because this side is 0 doesn't mean we automatically know what the end answer is going to be. You have to look at this piece. So I have 0 equal to 0. Does that make sense? Yes. If I have no money, you have no money, we are the same. We po. Okay? So this makes sense. So what did that mean for the solution? No. It's an infinite. Because this makes sense, this is one of our special answers. It's the infinite answer. Yes. If all of your variables cancel out and you're left with two numbers and they're the exact same, infinite. If this was different than that side. If I had 0 equal to 3, does that make sense? No, if I have no money and Jabez, you have $3, you get to go to Taco Bell, get $3 worth of tacos, and I get to stare at the window looking at you hungry. We're not the same. You get Taco Bell tacos, I got nothing. That's why I say you have to make sure that you look at both sides. Because if you're the same value, you're infinite. If you are different values, no solution. Okay? Now, if your variable didn't cancel out, well, then you got an answer. So you keep going. Okay? But this is one of those infinite answers. Everything works. Cool beans? All right. Notice this guy says substitution. And again, you could do any method you want for this. If you like to do elimination, you could do elimination on this. If you want to go into your calculator and graph it, you can go into your calculator and graph it. But this really is going to be the easiest with substitution. This is 2.4. So with substitution, what was the goal of substitution? Before I can do any substitution steps, what did I have to make sure happened? We have a variable by itself. Do I have a variable that's by itself up here? Yes. Who? The top one, x. I know what x is. Right there, the goal is met. It's ready for substitution. Okay? So what am I going to do with this y minus 3 then? Plug it in where the x is in the second equation. Take this, shove it in right there. Okay? Substitute it in. That's what substitution is all about. Take what you know and substitute it into the other guy. So we're going to have negative 4 parenthesis y minus 3, because that's what x was, plus 12y equal to 4. And now all we got to do is solve for y. So what are we going to do first? Distribute. So negative 4 times y gives us negative 4y. What's a negative 4 times a negative 3? Positive 12. Come on. Okay? And then we still had the plus 12y equal to 4. Now what are we doing? Minus 12 to both sides, that's fine. But again, I want to put my variables together. Because what happens if my variables might disappear? Then we'd be done. So let's put our variables together. What's negative 4y and a positive 12y give us? 8y. 8y plus 12 equal to 4. Yeah, combine those like terms. That's what we just did. Now what? Yeah, minus 12. Boom, minus 12, minus 12. 8, stop it. 8y equals, what's 4 minus 12? Negative 8. And then we're going to divide by 8. So y is equal to negative 1. So my variable didn't cancel out. I got an answer here. So that's why we keep going. This is not one of those infinite or no solutions. We have an answer for y. We know that y is negative 1. So what am I going to do with this piece? We're going to plug it in. We're going to go back to one of these original equations up here. And it doesn't matter which one. And we're going to plug in negative 1 for y and figure out what x is. Which is going to be the easiest one to plug into? Yeah, the top one. So x is equal to negative 1 minus 3. Because we knew that y was a negative 1. So what's negative 1 minus 3? And there's the answer. Negative 4 comma negative 1. No, it's not based on the smallest first. It's based on the fact that this was x, which was negative 4, and the y was negative 1. Because points are written as x comma y. And then all we did was went and plug it back into one of those equations. Didn't matter which one. Yeah. Cool? All right. All right, question number 11. We are a third of the way through. So question 11, another application of systems. And again, this is going to be coming from that section 2.4. That's where this problem's coming from. All right. So it says Nate has 81 coins made up of quarters and half dollars. You know what a half dollar is, right? 50 cents. Okay. Quarters are what? 25 cents. All right, cool. So we got 81 coins that are made up of quarters and half dollars. The total value is $30.50. How many quarters and how many half dollars does Nate have? So when I taught this in class, I said that there are two ways that you can look at these application problems. They're either translations, where they're basically telling you the equation in words, or they are what we call standard form. If you look at this, do you see any words up here that relate to mathematical symbols? Like, do you see the word sum, difference? Well, other than total. Okay? Times. Do you see anything that says times and stuff like that? Do you see any of those words? Then this is not a translation. A translation would read like 3 times some variable plus 5 is 22. That's a translation type sentence. I'm using mathematical symbols as words. This is a standard form equation. Because we have the word what? You said it a moment ago. Total. If you have totals, you are writing standard form. And you have totals. There's one of them. Equal to 30.5. Do I have another total? Yeah. Who is it? 81. That's how I know this is standard form. I have totals. And standard form is always equal to a total. Okay? Now we just need to write out the equations to these. Now the weird thing is, you've already used up all the numbers. So we have to rely on what we know about some of these, which is why I asked you earlier. Do you know what a half dollar is? It's 50 cents. Do you know what a quarter is? 25 cents. We're going to use those 50 cents and 25 cents in one of these equations. Which one do you think we're going to use that in? The bottom one? No. The top one. Because 50 cents and 25 cents and $30.50 is all about money. This is our money equation up at the top here. So when I write this equation, because this is over here in dollars, I can't just put 25 and 50 over here. They need to be as their decimal versions. 0.25, 0.50. You follow me on that? Because we are in dollars over here. So 50 cents in terms of dollars is 0.50. 25 cents in terms of dollars is 0.25. Now, I need variables, though. Q and, say it again, F. F will work. Or you can call it H for half dollar, Q for quarter. So who's getting the Q? 25. Who's getting the H? The 50. And what sign will be between them? A plus. There's your first standard form equation. And again, this equation makes sense because this is all about 25 cents. This is all about 50 cents. This is all about how much money I have. Money, money, money. How much is a quarter worth? Okay? Yeah. So you had to know a little bit about American money. Okay? Now, what's the next equation? Q plus H. Because this is all about the amount of coins I have. And however many quarters plus however many half dollars better be 81. So this is all about coins, coins, coins. Money, money, money. Make sense? Now all we do is pick our method and solve it. Pick our method and solve it. Okay? You can do elimination, you can do substitution, you can try graphing if you know how to work your calculator really well. The easiest one on this one, I do elimination. Okay? Logan, pick a variable, Q or H? Q. All right. So, what number am I going to turn Q into? Because I got a 1 and I got a 25 cents. Say it again. Negative 25. Good. So I want a positive 25 and I want a negative 25. So do I have to do anything to the top equation? No, it already matches. See, look. 0.25, 0.25, already matches. We're already good to go on that. What do I got to do down here to turn the 1 into a negative 0.25? Yeah. Times it by that negative 0.25. Okay? So our top equation stays the same. But our bottom equation is now going to change. So negative 0.25 times 1 is negative 0.25, which we knew was going to happen. What's negative 0.25 times 1? Another negative 0.25. What's negative 0.25 times 81? Negative 20.25. Everyone good so far? All we did was multiply through. Oh, yes, thank you. Good catch. Negative 20.25. And now what are we going to do? Add down. So just like what we engineered, Logan says let's get rid of Q. So the Q is gone. What's 0.5 minus 0.25? 0.25. H equals what's 30.5 minus 20.25? 10.25. Perfect. And now what are we going to do? Divide by 0.25. Good. So H is equal to, and this should come out to a nice, neat number. Say it again. 41. Now what do we got to do? We got to plug it in because we've got to figure out the number of quarters. Which one of my blue equations is going to be the easiest one to plug into? The bottom. Because these are all nice numbers. Why go into something that has decimals? That's just silly. So, we're going to take that 41 and we're going to plug it into H. And we're going to figure out how many quarters we got. So, Q plus 41 equals 81. What do we do now? Yeah. Minus 41, minus 41. Q is equal to 40. And now you know the answer to the problem. there are 41 half dollars and 40 quarters. Now I can see why I use those descriptive variables. If I had x and y up there, then I'd have to go back and look and see what x and y meant. When I change my variables to stuff like q and h, it lets me know without having to go back up that, oh, q is about quarters. There are 40 of them. The h was about half dollars. There are 41 of those. You could have done substitution on this one and gotten the same answer. You could have went into your calculator and graphed it, although you'd have to manipulate your calculator a little bit more than usual to get to the answer. But there it is. When you do this problem in on your test, it should come out nice and neat like these. If you get decimals for these, I know that you're doing it wrong, because if I got a decimal of 0.3, what would 0.3 of a quarter look like? That's just weird. Okay? So when you do this problem, you should get exact answers. If you get a decimal or a negative number, because we can't have negative money, you know that you need to go back and fix. All right. So we are now in chapter 3. And we are in 3-4 right here. Long division. Okay, so we need to do some long division. And we're going to find the quotient and the remainder. So when I divide, which part goes under the division symbol, the numerator or denominator? Say it again. It's not the denominator. It's the numerator. The numerator is what goes under your division symbol. The denominator is what goes out front of your division symbol. So there's what we're looking at. Also remember with long division, the piece that's under the denominator, what are the two things you have to watch out for? Nope. The variables are in order. So make sure that you're in standard form. So 2, 1, 0. So that's good. And you also have to make sure of what? One other piece. Make sure you're not missing anybody. So if I said 2, 0, notice I skipped over the number 1, right? If you are missing that x variable, then you got to put in the placeholders for it. So watch out for placeholders under here. So two things again, make sure you're in standard form, and make sure that you don't have anybody missing. Missing terms, you got to put them in with a +0 and that term. All right, so let's begin. Remember I told you in class that long division is just like regular division of numbers. It's all about getting rid of numbers and canceling stuff out. And you do it in 3 steps. So right now, who is it that we're trying to get rid of? We want to get rid of this guy. Okay? So we need to ask ourselves, what times x, because this is what we're going to be working with, will give us x squared. X. So that's what goes right up here. X times x will give us x squared. So now we're going to take this x that we have up at the top, and we're going to multiply the polynomial that was in front of our division. So what's x times x? And we knew that was going to happen, because we're engineering it so that that would happen. And what's x times -10? And we line that up under the other x. And then what do we now do with long division? We subtract down. Good. So what's going to happen to our first x squareds? they go away, which no surprise to us. But remember, I always in class told you that I would do this. Whenever I look at everything else, I always write down what's really going on. So what we have here is a negative 4x minus a negative 10x. So that looks like this. That's what's really going on there. So what do I get when I take negative 4x minus negative 10x? A positive 6x. And it's when we subtract down over here, that's where students get messed up. Because you forget that you're subtracting down and that this subtraction will affect that bottom guy. And then what happens with my 10 out here? Bring it on down. Trickles on down like Tetris. Now who are we trying to get rid of? The 6x. So now we have a new focus, and we're going to repeat the process over again. That's all that there is to long division. Repeating these 3 steps that you see right here. So, what times x will give us 6x? 6. So we're going to come up here, and we're going to put a positive 6. And then we're going to distribute that, just like what we did with the x earlier. So 6 times x minus 10. So what is 6 times x? No surprise there. What is 6 times negative 10? Negative 60. And then what are we going to do? Subtract down. So what's going to happen to the 6x's? Gone. That's not a surprise. We were engineering that. But then over here, we've got 10 minus a negative 60, which gives us what? 70. And that's our remainder because there's nothing else that we can do. So, it will ask you these 2 questions. Quotient with a blank. Remainder with a blank. So what's the quotient? The x plus 6. Everybody that's above my division sign. What's the remainder? 70. Or the other thing it could ask you to do is to write it all out as one answer. Okay? So if I write it all out as one answer, it would look like this. X plus 6 plus our remainder, which is 70 over what? The x minus 10. Whatever's in front of your division sign goes under the remainder. So it could ask you to write it like that, just so you know. Yes, if it just asks for the remainder, just put the number 70. Do not make it a fraction, it will count it wrong. Although that's really how it should be written. So technically this is the better answer than what it has you do up there. Okay? Any questions? So this piece right here was your quotient. This piece right here was the remainder. All right. All right. Now we are in 3536. Factoring. All you have to do is be able to factor. Okay? So, when you factor, what is your first line of defense? A GCF. Is there a GCF in here? No, not right off the bat, but I will tell you, when you are dealing with factoring, whoever your highest power is, most of the time for us it's 2 or 3, we always like them to be positive. Is my highest power in here positive? No. So we need to fix that. What will turn a negative into a positive? Another negative, right? So technically, they do want you to pull a GCF out in this, and it's going to be a -1. Remember, pulling out a negative number will allow you to change signs. Pulling out a negative GCF allows you to flip the signs around. So it's no longer a negative r cubed. It's a positive r cubed. It's no longer a positive 8. It's a -8. Now, do not get me wrong. I probably would have left it the way it was because it's not... technically, this is ready to factor. We don't really have to pull out that -1. But I know what it's going to do in iMath.AS, and it wants you to pull out the -1. Okay? So, just kind of give you a heads up on that. Now, do you remember how to factor a cubic? That's the ultimate question. Yes, it's a formula, Lorraine. It is a formula. There were two formulas that you needed to remember. There was what we called the sum of cubes, which that is not this one, because this is not addition. But the sum of cubes, it looks like this. It was a formula. A plus B was your first parenthesis, and then you had a squared minus AB plus B squared. That's what the sum of cubes formula looked like. And then there is a difference of cubes. And that's what we have here. And there was only a small change between the sum to the difference. So what does the difference of cubes look like? A minus B. And then A squared plus AB plus B squared. The only difference between these two is where you put the minus. In the sum of cubes, it comes in the second parenthesis. In the difference of cubes, it comes in the first parenthesis. So all you need to do is take this information, figure out what A and B are, plug it into your little formula over there. How do I figure out what A and B are? Because this is a difference of cubes. Let me ask you this question. How do you get rid of something cubed? Not a square root, a cube root. That's how you figure out your A and B. Take the cube root of each one of these pieces. Take the cube root of r cubed. What is the cube root of r cubed? R. Take the cube root of 8. 2. Now you know A and B. So let's fill in. We got -1 in front, and then you got your two parentheses. What's the first parenthesis look like? R, keep going. Fill in. -2. Here's your first parenthesis. Now we're going to fill in the next piece. So r squared plus r times 2, which is 2r, plus 4, because 2 squared is 4. That is what they're going to be looking for. Say it again. That was difference of cubes. Sum of cubes works the same way. Okay? Sum of cubes works the same way. Got to figure out your A and B by taking cube roots, and then you just plug into that formula. Cool? All right. All right, jumping into chapter 4 now. So chapter 4, this comes from 4.2. No, 4.3. Because we did adding and subtracting second. I think. It's either 4.2 or 4.3. It's one of those two. All right. Remember, this is all about like the same way fractions work. How do we add and subtract fractions? Say it louder. You got to have a common denominator. Before you get that common denominator, what do you got to do to all these denominators? Because I can't find the common denominator right now. What do I got to do to them? You got to factor them. So the question is x minus 8 factored? Cool, so that's good to go. Sorry, I said x minus 8, y minus 8. Is y squared minus 13y plus 40 factored? No, so we need to factor that. All right, so the first denominator is factored, but the second one is not. Cool thing is, with this factoring, we're going to make it easy on you because we're going to keep the a as a value of 1, which makes factoring a whole heck of a lot faster. So what are we going to get? Say it again. Y minus 8, okay. Y plus 5. Are you sure on that one? Because a negative 8 times a positive 5 is not a positive 40. Two negatives, yeah. So y minus 8 and y minus 5. Because a negative times a negative is a positive, so that gives me the positive 40. And a negative 8 and a negative 5 give me the negative 13. So now we can find that common denominator. We can find that LCD. So what is the LCD going to be between these two denominators? Y minus 8 and y minus 5. It's going to be made up of both of them. Because that first parenthesis, y minus 8, covers the first rational. And then both of these parentheses help cover the second rational. So now we create our two rationals that will both now have the same denominator. Okay? So now we go back up here and we start looking. Here's what I have, y minus 8. Here's what I need, y minus 8, y minus 5. So what do I got to do to this top rational? It needs a y minus 5. So we're going to multiply top and bottom on this first rational by a y minus 5 because it's missing. Does that make sense? All right, so what is 6 times y? What is 6 times negative 5? Oops, I don't know why I put 13. 30. Okay. Now, look at my second rational. Here's what I've got. Here's what I need. Is there any difference? So then do we do anything to it? No. Since they match, don't change it. Don't go changing. So the numerator is still 18. Everyone good? All right. Now remember in class I said beware the subtraction. So what did I usually do with this subtraction to help us out? Yeah, I changed it to addition. And then what does that do over here? Yeah, changes everybody's sign on the other side. With subtraction, I go ahead and do that. Ah! There we go. So I turn the subtraction into addition, And then everybody in the numerator that follows, I flip all their signs. So the positive 18 now became a negative 18. All right, so now we're ready to do the adding and subtracting. Stop it. So we got y minus 8, y minus 5 down here, because when we add and subtract, we don't change the denominator. But what do we got in the numerator now? When we put these together now, 6y minus 48. Because it's all about combining like terms. These two are going to get together. And negative 30 and a negative 18 give me a negative 48. All right. And last but not least, we need to make sure that there is no reducing, no simplifying. So the denominator's factored. What do we also have to check? The top. So the question is, does this top 6y minus 48 factor? Yes. What's coming out? A 6. It's a GCF in the numerator. We got to pull out that 6. And we're going to see if anything is going to cancel. So I pull out the 6. I get y minus 8. All over y minus 8, y minus 5. So now that everything's fully factored, does anything cancel the y minus 8s? Because I got a y minus 8 on top and a y minus 8 on bottom. They're going away. So that leaves us with what for an answer? There you go. 6 over y minus 5. Make sure that you do use the variable y if you're on the computer in iMath AS. Super important. I shouldn't take off for anything. So if you did put parentheses around that, that should not count off for that. Yeah. But you could also use, again, remember, there's going to be a box here, and you got that little drop-down menu right here. In that drop-down menu, you can make it look like the fraction and not have to worry about the parenthesis. Okay? All right. We're getting there. We're halfway. All right, so here we got a complex fraction. This is 4.4. Okay? How do we deal with complex fractions? Do we like fractions? So if you don't like fractions, what did I tell you to do with them? Get rid of them. So this is that clearing the fraction idea. So in order to clear the fraction, what do we need to know? What do you got to find first? Not the greatest common factor, the least common denominator. Got to find the LCD. Everyone's going to get multiplied by the LCD here in a second. So when we look up here, look at all those fractions. Who are all the denominators then? 24 and y. So what's the LCD going to be between 24 and y? 24y. That's right. That's what I'm about to do. We're going to play Oprah right now. You get a 24y, and you get a 24y, and you get a 24y, and you get a 24y. Everybody gets a 24y. So, what's going to happen between the 24y and the 24? Who cancels out? The 24's go away. You got it. So what am I going to be left with? Y squared. Because y times y is y squared. Because the 24's took each other out. What's going to happen between the 24y and the y? Y cancels. Gone. Gone. So I'm left with minus, what's 6 times 24? 144. Okay? So there's my new numerator. See, no more fractions. What's going to happen between the 24y and the 8? Because nothing's going to cancel. Because there's no denominator there. We just multiply. So what's 24y times 8? $192y plus, what's going to happen between the 24y and the y? Y's are going to cancel. So we need to know what is 96 times 24. $2,304. Oh, 4. So there's my new denominator. This is much easier to work with now, because all we're going to do is simplify. We're going to make sure everybody gets factored, and then we're going to cross off what's going away. Okay? All right, so the top, y squared minus 144. How does that factor? Yeah, it's a difference of squares. A y minus 12, a y plus 12. It's a difference of squares. All over. Now on the bottom, what kind of factoring are we going to do? We are going to pull something out. Use the L's, or the GCF, I think. Or is it the LCM? Actually, it's the LCM. Yeah, you're going to pull out 192. Both numbers can be divided by 192. So we pull 192 out. What's that going to leave me with in the parenthesis? Y plus what? Plus 12? Okay. And that's not surprising to me. So everything's factored. What's going to happen? Yeah, y plus 12s are going away. See ya. So what do I have in the numerator then? Y minus 12. What's in the denominator? 192. And do not try and take the 12 over the 192 and reduce, because you can't. This 12 right here is with that y value. Okay? That is the final answer. Yeah, I'll do that after this one. Cool beans? All right. Now we're going to solve. This is 4.5, where you are solving. Answer. On the last problem. We're not going to... between these guys? Yeah, there's nothing that cancels because there's no denominator. So we went ahead and just multiplied those. 24 times 8 gives us the 192. And the y came along for the ride. Logan? Because it needs to be made up of both of them. Yeah. If you look at our denominators that we have up here, my denominators are 24, y, and y. So the least common denominator, remember what I said, it needs to be made up of everybody. So when we start writing down our denominator, because remember in class I said write down your first denominator. So 24 definitely covers 24, right? But does 24 cover the y? No. So what do I need to add in? A y. Because the 24y will cover the 24, and the 24y will cover the y. And since we're talking about LCDs again, that's how this problem gets solved. In order to solve this for y, and I don't know why they keep throwing y at us, but in order to solve for y, we're going to clear the fraction out because we hate fractions. So, who are our denominators again on this? 5y and 4y. So what is the LCD going to be between 5y and 4y? 20y. Okay? Because I got to get them both to divide a common number. The only common number both 5 and 4 can divide is 20. And since both of them have a y, we need the y to come along for the ride. So, again, play Oprah. You get a 20y. And you get a 20y. And you get a 20y. So what's going to happen between the 20y and the 5y? The 5y goes away. So does this y. But the 20 doesn't fully go away. The 20 becomes what? A 4. Because 20 divided by 5 is 4. So what do I have left for my first rational here? 12. That's it. Not over anything. We got rid of the denominator. It's just 12. Because 4 times 3 is 12. So what's going to happen between the 20y and the 4y? The y cancels and so does the 4. But the 20 doesn't cancel. It becomes 5. Because 20 divided by 4 is 5. So I got plus what there? 15. Because 5 times 3 is 15. And then obviously over here, nothing's going to cancel on that side because there's no denominator. So we just need to know what is 4 times 20y? 80y. That's a whole heck of a lot easier to deal with. So what's 12 plus 15? Okay. Equal to 80y. Now what? Divide by the 80. Good. Divide by 80, divide by 80. Y equals, and you're going to have to reduce that, if it can. It can't? So then that's our answer. Really ugly, but nevertheless, that's our answer. 27 over 80. But we're not done. This is actually our possible answer. Because remember in 5.4, you need to check these answers. And because what are we looking for to see if this happens? Make sure that who's not 0? The denominator. So up here, if I plug 27 over 80 in for y, if I multiply that by 5, will that give me 0? No. So far so good. If I take 4 times 27 over 80, will that give me 0? No. So then yes, that is our final answer. You need to check it. Because if any of these became 0, you have to throw that out. Okay? So this answer is valid. Whoops. It's on the erase. Because we didn't get any zeros in denominators with it. Okay? Well, it's just telling you what y is. Oh, so like when you go into your answer, do not put y equals because it will probably just have y equals and the blank. Okay, so you just put the number. Yeah. All right. So, an application that's coming exactly from 4.5. Okay? So this is coming out of 4.5 as well. So if you remember in class from the video, these application problems all take the same form. This is what one item, another item, and this is if they work together. They all look like this. Because you're talking about two people doing two separate jobs, and in the end they want to know what happens if we work together. Okay? So, if I read this problem, it says, Lauren can rake the leaves in her yard in 8 hours. Her younger sister can do the job in 6 hours. Working together, how long does it take them? Just like what I said a moment ago. So, 1 over, talk to me about the first person. 8. Because it takes Lauren 8 hours. Plus 1 over, talk to me about the next item. It's 6. Because her sister can do it in 6. Equals 1 over, do I know how long it takes them to work together? Call it X. There's the setup. All we got to do now is solve. Just like what we did in the previous problem. Find the LCD, multiply everybody by it, and then kick out your answers. So, my denominators are 8, 6, and X. What's the LCD going to be? Say it again. 24X. Because 24 can be divided by 8. And 24 can be divided by 6. Okay? So, everybody up here is going to get multiplied by 24X. 24X. X. 24X. So what's going to happen between the 24X and the 8? 8 goes away, and the 24 becomes a 3. So what do I have here? 3X. Good. Because 3X times 1 is 3X. And then we have plus, what's going to happen between the 24X and the 6? 6 goes away, and the 24 becomes a 4. So 4X times 1 is 4X. Equal to, what's going to happen over here between the X's? Yeah, the X's go away, leaving us with 24. Much easier to solve there. So 3X plus 4X equals 24. What do we do now? Combine like terms. So 3X and 4X equal to 24. And now what? Divide by 7. Good. So X is equal to 24 over 7. Hours. Yeah, and it wants it as a fraction, although since this is a word problem, that's just weird to say, oh, it's going to take us 24 over 7 hours. Most people do not talk like that. Okay? Most people would say this is going to take us 3 hours and some odd minutes or whatever. Okay? It's just a weird answer with the way they want us to put it in. Any questions on that? And that will end chapter 4. Now we move into chapter 5. So this part comes from 5.2 over scientific notation. So we're going to multiply these two scientific notation numbers. Do you remember how to multiply these? For my class, I had a video over this. Yeah, we're going to take these two numbers and we're going to multiply them. So what is 2.7 times 1.2? Say it again. 3.24. And then we're still going to have the times 10, but then what are we going to do? With these, you're going to add them. Because when you multiply exponents that have the same base, you add the powers. So add those, multiply those. So what is negative 3 plus negative 4? Negative 7. Okay? The last thing you do is you check your number right here and make sure that it is between 1 and 10. If this number is not between 1 and 10, then pretty much what you have to do is you got to move your decimal either to the left or to the right to get it there. Okay? But 3.24 is between 1 and 10, so we're okay. That is the final answer. Just know that if you do have to manipulate this, that also affects the power. If you move it to the left, you got to add on to the power. If you move it to the right, you take away from the power. Okay? But that is the final answer. All good right there. Okay? This one, if memory serves correct, is still coming from that same section 5.2. It's all about exponential properties. Yes. 5.2. So what are we going to do with this? What do they want us to do? What do they want us to do in this problem? Distribute. That's it. And as I multiply through, what do I do with those powers again? Add them. Because when you multiply, you add. What is the power on the m? 1. Stop it. And what number is in front of the m? A 1. So I'm going to put those invisible ones in there because they help us out. So we're going to take 7 m to the 3/4 times 1 m to the 1st. So again, what's going to happen between the 7 and the 1? What is going to happen between those? You multiply. They're not powers. They're just regular numbers. 7 times 1 is 7. Now with your m's, what are we going to do with the 3/4 and the 1? That's where you add. So we'll get m to what? So you go to your calculator, you take 3/4 plus 1, and you get 7/4. There you go. So there's the first part. And all you do is just do it again for the next piece. Distribute to it. So what's going to be the 7 times the negative 2? Negative 14. And what am I going to do with those powers again? Add them. So we're going to take 3/4 plus 1/2. Five-fourths. There you go. That's it. That's the answer. Okay? You can see how it kind of starts to pick up pace a little bit once we get into these later chapters. All right. Rationalize. So this is coming from 5.4. This is coming from 5.4. Normally, when we rationalize, all you have to do is multiply by whatever radical is in the denominator. But this is a little different because you got addition and subtraction in the denominator. So do you remember how we rationalize when we have addition and subtraction in the denominator? What do we have to do? What do we have to use? Say it again. The opposite sign. Conjugates. You got to use conjugates. What is the conjugate of 3 minus the square root of 12? So that's what we're going to use to rationalize. That's the only way we're going to get rid of the radical in the denominator. Because some Joe Schmo mathematician long ago whined about having irrational numbers in the denominator. So, let's talk about the denominator. All that's going on is the FOIL process, first, outer, inner, last. But since we know that the radical is going to disappear, and these are conjugates of each other, how did I tell you really to multiply conjugates? And it's really super fast. Not good child, bad child. What were you saying? Say it again. First and last. Florida. All you have to do in the denominator is multiply the first, multiply the last. I call it the Florida. So all we're going to do is take 3 times 3. It's what? 9. Not negative 9. Positive 9. And then what happens when I take two radicals that are the same and multiply them? It pops out. So what's a negative times a positive? Negative. And the square root of 12 times the square root of 12 is just 12. Because, and the reason why we don't have to do the O and the I, the outer and the inner, is because they cancel. Okay? When you have conjugates and you FOIL them, that's what happens every time. So really all you have to do is multiply the first, multiply the last. So what, say it again. Yeah, if these two are the same radical, all that happens is the number pops out. That's a nice little property of radicals. But it only works if they're the same. So what is 9 minus 12? There's your denominator now. Now we got to work through the top. All right. So what are we going to do on the top here? Yeah, we're just going to multiply. We're going to distribute. What's negative 5 times 3? Negative 15. What's going to happen when I try and take a negative 5 times the square root of 12? Yeah, negative 5 square root of 12. They don't really multiply each other, but they don't disappear, so it just gives you negative 5 square root of 12. So here's what we're looking at. So this is where we need to now start thinking about simplifying. And in order to simplify, the first thing you're going to take care of is the radical. Can the square root of 12 simplify down? Yes. What does it break apart into? Square root of 4, because that's our perfect square, and 3, which is not the perfect square. What is the square root of 4? 2 with radical 3. So this piece right here, this 2 radical 3, it's going to come over here, and we're going to replace the square root of 12 with it. What's going to happen between the 2 that's in front right here and the 5 that's right there? They're going to multiply. Good. So that would give us negative 15 minus 10 square roots of 3 all over negative 3. Because the 5 and the 2 multiplied each other. That's where the 10 came from. And then now, look at your numbers on the outside. Negative 15, negative 10, and negative 3. Is there any number that can divide all 3 of those? Then that's the final answer. One thing you could do, since the bottom is negative, remember that we can take negatives and we can move them in different places. So another answer that's valid would be negative 15 like this over a positive 3. Or we could take that negative and move it up top. And we could have, what would a negative 15 turn into if I move that negative up top? Positive. What would a negative 10 turn into if I move that negative up top? A positive. They're probably looking for that answer the best. Because you got a bunch of negatives divided by a negative. What happens when you take negatives divided by a negative? Positive. So there you go. So technically there was a number that divided all of them. It was really -1. Sneaky on their part. But I don't know. I'm hoping they don't give you one that's kind of sneaky like that. Okay? Any questions so far? Okay. 2/3 of the way down. 10 more problems. Okay. So this guy coming from 5.5. So we're solving. Before I can solve this radical, what do I got to do first? Say it again. Nope. I can't bring him out of the radical yet. Nope. It's not a factoring issue. Not equal both to 0. This is a lot like my question that I had for you when we were dealing with the absolute value. What did you have to make sure in the absolute value? Not that it equal to 0. That your absolute value was by itself. What do you have to do on this? Get a radical by itself. So again, remember, you pick one. Let one of these become the original radical. Take the other guy, move it away. So usually I just let this guy, again, we're back to that y. I love y. I'm going to let this be my original radical. So how do I get rid of a minus square root of 36 minus 4y? Add it. We're just going to pick it up and we're going to move it to the other side. No equal there. Okay? So we're going to have the square root of 3y plus 15 equal to what? Equal to the square root of 36 minus 4y. So is my radical right here, the square root of 3y plus 15, is it by itself? Yes. Because everybody under the radical is protected, just like inside the absolute value, it was protected. So this radical is by itself. All right, now we can start to solve. How do you get rid of a radical? What takes care of a square root? You square it. That's right. How do you get rid of a square root? You square it. So we're going to square both sides. What is a square going to do to those radicals? Say it louder, Yolanda. It's going to get rid of them. That's right. Because squaring undoes a radical. And vice versa. A radical undoes something squared. So what we have left is 3y plus 15 equal to 36 minus 4y. We could have only done the squaring once that radical on the left side was by itself. Okay? All right, what do we do now? Move the y's to one side. So who are we going to move? The first y, all right. So how do I move a 3y? Minus 3y. Minus 3y. So you got 15 equal to what? 36 minus 7y. Okay? Good. Come on. Now what? Take away the 36. So what's 15 minus 36? Equal to negative 7y. Now what? Divide by negative 7. Divide by negative 7. Y is 3. You're not done. You got to check it. Because this is our possible answer. We got to make sure it works on both sides. Okay? So, technically, all we really actually have to check. Oh, did it move on me? Yeah, it did. No worries. Technically, all we really have to check is plugging in the y value here and making sure it equals 0. So let's double check that. So our y value was 3, right? So what's 3 times 3? 9 plus 15. 9 plus 15. 24. So we have the square root of 24 there. Okay? Let's check over here. What's 4 times 3? And what's 36 minus 12? If I take the square root of 24 minus the square root of 24, is that 0? You bet. So is my answer valid? You bet. So in the end, I can put 3 in for my answer. It's good. Okay? All right, question 22. Here we go. So again, this is coming from 5.5. It's a word problem. They're giving you all the information you need to do. You just need to do kind of a little bit of plug and chug again. Okay? So up here it says police officers use the formula S equals the square root of 30 FD to estimate speeds of cars and miles per hour, where D is the distance in feet the car skidded. F is the coefficient of friction. If the coefficient of friction on a certain gravel road is 4, and the driver of the car claimed to have been driving 60 miles per hour, find the distance the car skidded. All right. So the 4 that we have here. Who is that? That's F. That's the friction. So we're going to plug 4 in for F. The 60 miles per hour, who is that? That's your speed. That's S. So who are we looking for? D. So we're going to plug in the 60 equal to square root of 30 times 4 times D, right? Because we don't know D. All right, so what do we need to do? How do I solve for D? So it's just like what we got done doing a second ago. Say it again. Okay, let's deal with inside first. So what's 30 times 4? So I have 120D, square root of that, equal to 60. All right? That's as far as we can go on the inside. Now what? Can I raise both sides to the power of 2? I don't know, that's what I'm asking. Yeah, you can. Why? To get rid of the radical. And remember that in order to raise both sides to the power of 2, you have to make sure your radical is by itself, right? Is your radical by itself? Yes. Because remember, everything under here, the 120D, is protected by that radical. We're trying to get rid of the protection. So this radical is by itself. So we're ready to square it. We're ready to raise it to that power of 2. So what is 60 squared? 3,600. Equal to now 120D. Now what do we do? Divide by what? 120. So what is D? How much? Oh, I thought you said 30. Oh, you said 30. Look. All right. 30 feet. So our driver skidded 30 feet. That's a long skid. Does that make sense on this? You're plugging in, and then you're doing a little bit of solving like what we just did on the previous problem. Make sure that your radical is by itself before you square both sides. All right. Like there's nothing else out here around it. Like there's no like +3, -8, no number in front of it like 2 or anything like that. You got to get all that stuff away from it before you square it. So if there was a 2, how do you get rid of multiplication? We would have divided by 2 on both sides. Yep, and then do the next step. Yeah. All right. So now we jump into chapter 6. So right here, it says use factoring. Again, in chapter 6, those first few sections, 6.1, 6.2, and 6.4, you learn 3 different ways of solving quadratics. You learn factoring, you learn the quadratic formula, and you learn square roots. You can't use square roots on this one because you have a middle term. Whenever you have a trinomial, you can't use square roots on it. So even though this says factoring, which it is factorable, you could also use the quadratic formula on this. We will never know. Okay? So it's your call. But I will tell you, factoring is probably the easiest on this. It is your fastest. So, what does this factor to? Hopefully you've gotten good at factoring by now. And since A is 1, it makes things a whole heck of a lot easier. Say it again. X minus 8 and X minus 7. And now that it's factored, what am I going to do with these parentheses? So yeah, set them each equal to 0. So take the X minus 7. Set it equal to 0. Take the X minus 8. Set it equal to 0. This is what we call our zero product rule. So now you know what the 2 answers are. X is equal to what? 8. So that's this guy. And X is also equal to 7. Done. And you don't have to worry about checking these answers. Although you can plug them in and check it. If you plug them in and see that it will give you 0 on both sides. Okay? Also, just always important to note for you again, in order to factor and use the quadratic formula, you must be equal to 0. If we were not equal to 0, we would fix it. But in order to factor and in order to use the quadratic formula, you have to be equal to 0. You with the hand raised. No. It doesn't look like anything up here says put it in this way, but it's always good to read that fine print that they always put on there. Yep. Okay. Notice up here it says use the square root method because that's the best method to use on this. And using the square root method is just like what we were doing when we dealt with absolute values and square roots. Before I can take a square root of both sides, what has to happen? Before I take a square root of both sides, what do you got to make sure is A-OK? It's just like absolute values. Yes, it's got to be by itself. Whatever is squared has to be by itself. So here's my squared idea. Is it by itself? Yes, because everybody in the parentheses is protected. Okay? There is nothing outside of this. So, since it is by itself, can I take a square root of both sides? You bet. Because a square root is what gets rid of squares. So, we got 5t minus 1 equal to what? No! I I told you not to forget this. Say it again. No. I said, do not forget this in front of the answer. Plus and minus. The ultimate killer of every algebra student. Plus or minus 2. Oh, just so you know, this is coming from 6-2. The previous problem with factoring was 6-1. So yes, you got to have plus or minus in front of that. I like the 2. I just didn't like that you told me it was 2. Because there are 2 answers to this. Without the plus or minus, you'll only get 1. All right. So remember in class, I said this plus or minus kind of makes this problem like 2 separate equations. You have one equation that is 5t minus 1 equal to a positive 2. And then you have another equation that is 5t minus 1 equal to a negative 2. So if you want to separate it out into its 2 equations and solve, by all means, do it. I usually just run it all together. And I solve it as one equation. And then in the end, I worry about the 2 answers. So, how do I get rid of a minus 1? Add 1, right? Plus 1, plus 1. But again, because this thing is acting like 2 separate equations, I can't just take and add 1 to the 2 and say it's plus or minus 3. It doesn't work like that. So what I have here is 1 plus or minus 2. Don't put those 2 together. Because it's like you're running 2 separate equations at the same time. You follow me on that? And then now, how do I get the t by itself? Divide by 5. So t is equal to 1 plus or minus 2 all over 5. And this is where I'm going to get my 2 answers. Because one of my answers will be 1 plus 2 over 5. The other answer will be 1 minus 2 over 5. So what is 1 plus 2? 3. And if that's over 5, does that reduce? No. So one of your answers is 3 over 5z's. Because 1 plus 2 is 3, and 3 over 5 does not reduce. What's 1 minus 2? Negative 1. Does a negative 1 over 5 reduce? No. So there are your 2 answers. A positive 3/5 and a negative 1/5. Oh, t, yes. Stupid variable change. T, x, it's all a variable to me. You would get the same answers had you solved these each separately. I just work it together as one because I like to work smarter and not harder. Okay? All right. Next guy. Solve using the quadratic formula. And now look, over here, this is how they want your answers to be. They want you to actually have them separated out by commas. Remember the quadratic formula? If you don't know it, remember I said you can go out to YouTube and search quadratic formula and you can hear a lovely song to Pop Goes the Weasel. But the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. It's a plug and chug idea. The a, b's, and c's up there are the same a, b's, and c's that you probably talked about when dealing with factoring. Minus 4ac. I know, it's my Egyptian hieroglyphics that are over here. Okay? So in class, when I taught this, remember that I said I usually run the discriminant first, and then I worry about the rest of the formula. Because if something goes wrong, the discriminant right here is usually where it goes wrong at. Okay? So all we're going to do is plug into the b squared minus 4ac real quick, because I want to get that number. All right. Before I plug in, I always like to write out who my a, b, and c are. Who is a? 4. Who's your b? Who's your c? Yay. All we got to do is plug those numbers in. So who is b again? 3. So I'm going to have 3 squared minus 4 times what's your a? 4. What's your c? All right. So in class I said I figured this guy out first. What is 3 squared? 9. And then in class I said I take care of these 3 numbers right there and multiply. I do not include the minus with the 4. So I want to know what is 4 times negative 6. 96? Negative 96. 4 times negative 6. So now what I do with the sign is I bring it down, because what they want us to do is to subtract these 2 answers. Yep. I treat this 4 as a positive 4. It is not negative, because that's where we get in trouble as algebra students, is you think that this guy is negative, and then down here you start messing up signs, and that's where it goes all haywire. All this says right here is find this squared answer, find these 3 numbers multiplied together, and then subtract it. So what is 9 minus a negative 96? $105. Because what happens with 2 negatives by each other? Becomes positive. So it's 9 plus 96, that's 105. So this is the number that is under our square root. And that's what I do now. I deal with the rest of the formula. All I'm going to do is go up, and now all I have to plug into is this and this, because we already know that. So I kind of break it apart that way. So let's plug in. X equals, what was b again? 3. What's the opposite of 3? Plus or minus, what number's under that square root again? 105. All over 2 times your a. What was a? 4. So what's 2 times 4? So this is what we're looking at. All you have to do now is simplify, if it can. So we look at this square root of 105, just like what we did with the rationalizing problem. That square root of 105. Can the square root of 105 reduce? Can we reduce that down? Because I know it's a decimal. So try and find me the biggest perfect square that might divide it. I don't know if it does or not. That's why I'm asking. My gut tells me that it doesn't. Yeah, it doesn't break down. It stays. How did I check it? Remember, I just start dividing by perfect squares. My first perfect square is 4. 105 divided by 4 is not a nice number. It's a decimal. Then I check my next perfect square. 105 divided by 9. Nope, doesn't work. Then I check the next one. 105 divided by 16. Nope, still a decimal. Then I divide it by 25. Then by 36. And then by 64. And then by 81. None of those are working. None of them come out to a nice, neat number. So the 105 stays. So then we look at our outside numbers. -3. There's a 1 in front of that radical. And 8. Is there a number that divides all -3, 1, and 8? No. So that is the final answer. But they'll want us to separate these into their two answers with a comma. So first we checked out the radical to see if it can reduce. And it doesn't. And then I looked at all my numbers that are on the outside. The -3, the 1, and the 8. Is there a number that divides all three of those? If there was, I would divide them all by it. But since there's not, you leave it alone. So now we write out our two answers, just like what they wanted us to do up here. Okay? So one of my answers is -3 plus the square root of 105 over 8. Comma. The other answer will be -3 minus the square root of 105 over 8. And that's how they're going to want them. Okay? And it looks like they'll want the minus version before the positive version. Okay? So it looks like they'll want the minus version before the positive version. So this guy right here, whoa, go back. So they'll want this to happen. Well, I should have moved that up here. Like that. They'll want the minus answer first, then the positive answer. Okay? Comma between them. Don't put any spaces. Application problem. So a ball is thrown upward with an initial velocity of 78 meters per second from a cliff that is 60 meters high. The height of the ball is given by this equation right here. Okay? Where h is in meters and t is the time in seconds the ball was thrown. So it says find the time that the ball will be 22 meters from the ground. So who are we looking for, T or H? Say it again? No. It says find the time. You're looking for T. So that means they're telling you who H is. Who is H? 22. So we're going to take this 22 and we're going to plug it in right there. Okay? This problem is definitely coming from 5.4. Which is what we were just in right here too. 5.4. It's a quadratic formula. This problem is a quadratic formula problem once we get everything in there. So let's plug in. The best part about this is we don't have to keep our answer exact. We'll get to do some rounding in the end. So that makes this a whole heck of a lot easier to use the quadratic formula. So we're going to take this 22. We're going to plug it in. So 22 is equal to -4.9 t squared plus 78t plus 66. We want to run the quadratic formula, but what did I tell you earlier about factoring and the quadratic formula? We cannot run them unless what? Nope. Someone said something. You got to be set to 0. So how do I fix this real quick? Minus the 22 to the other side. we got to be set equal to 0. If we are not set equal to 0, we cannot run factoring or the quadratic formula. So, negative 4.9 t squared plus 78t. What is 66 minus 22? Now you have all of your information to run the quadratic formula. Okay? Because what value is A? Negative 4.9. What value is B? 78. What value is C? 44. All right. So, we're going to run that x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. But again, remember in the end, we get to round. So we don't have to worry about reducing the radical or reducing the fractions. We just got to get all of our numbers where they need to be. So, let's run that b squared minus 4ac again. What's your b? 78, all right. So we'll need to get 78 squared minus 4 times what's your a? Negative 4 point what? 9. What's your c? Okay. So, what is 78 squared? And these numbers are going to get big. That's okay. 6,084. Okay. What is 4 times negative 4.9 times 44? What is 4 times negative 4.9 times 44? Say it again, Yolanda. Negative 862.4. And then we bring down the minus sign. So what we're really looking at is 6,084 plus 862.4. What do I get when I add those two numbers together? $6,946.4. There's our number under the radical. You can see why we don't want to try and keep this exact. I mean, we already got decimals in the answer. That's a pain in the rear. All right, so now we just plug into the rest of the formula. What was our value of B? What's the opposite of a positive 78? Negative 78. Plus or minus square root of, what number's under there? Yep. 6,946.4. All over 2 times A. What's our A value? Our A value is not 78. Negative 4.9. So take 2 times negative 4.9. Negative 9.8. This is the number that we need to put in our calculator. Now, there are 2 answers there, but one of these answers isn't going to make any sense. And that's going to be the one when we subtract. Because remember, this isn't really about x, even though I put x there. This is all about time. If I do the subtraction, that gives me a negative, well, no, wait a minute. Actually, we will want to work with the negative answer. It's the positive answer that when you do the addition, that gives us the messed up piece. Actually, I take that back. Just kidding. We actually need both answers. Sometimes there will be an answer that doesn't make sense, because if you end up with a negative answer to this, since it's about time, would that make any sense? No, a negative answer in time would mean we're going back in time. And we're not that good yet. And if you've invented how to do that, let me know. I will go into business with you. Okay? So in this one, we need 2 times, because there are 2 times when my ball is actually 22 feet off the ground. When it's going up and when it's on its way back down. So we do need both answers to this. So you need to go to your calculator and you need to type this in very, very carefully. Okay? Yes, Habez. So let me show you how that's going to work. Let me bring up my calculator. And you're definitely going to want to use the fraction feature on your calculator, which is by pressing alpha and y equals, because we're going to make this fraction. And if you use that feature, I'll show you a way to help us speed things up to get the other answer really, really quick. All right. So, remember I said we're going to use that fraction feature. So you can push alpha, y equals. And we want to run number 1. So all we got to do is put in the fractions that we have. Negative 78 plus second x squared to get your square root. And then now we put in the 6,900 and what do I want to? 46.4. And then down below, you put in the negative 9.8. That's one of our fractions, right? Hit enter. Well, actually, is this answer going to make sense for us? No. So it's a negative time. So that answer is one that we have to throw out. So, yeah, I was right. One of these answers we did get rid of. Okay, everyone good so far? Okay. Here's how we can get the other answer, because all we got to do is go in and change that to a minus, right? Hit second enter. There's the fraction we just had. Or you could scroll up to the fraction and hit enter. 2 ways to bring it back. And then all you need to do is scroll in to that sign and hit minus. And now you're ready to get your second answer. Hit enter. Round to 2 decimal places. What do you get? 16.46 seconds. And that's the answer they want. Because that first answer we looked at didn't make any sense. We can't go negative 0.5 whatever in time. But if you did, yeah, you separate them with commas. Okay? All right. This is 6.4, since we're using the quadratic formula. Okay. We're getting there. All right, this is coming from 6.5. This is 6.5. So it's all about taking this equation, and if you can break it down, what the A, H, and K are doing, you're going to know which picture to grab. So up here, remember A controlled 2 things. It controls whether it's a U, it opens up, or whether it is an arch, it opens down. And A controlled that by whether it was positive or negative. So your A value up here, what is A? It's 1. It's the number that's in front of our parenthesis right there. A is a positive 1. So is that going to be a U, or is it going to be an arch? Is it going to open up, or is it going to open down? It's going to open up. It's going to be a smiley face. So any of my pictures below that are arches, throw them out. Which, I don't see it. Ooh, there's lots of stuff to this question. So, none of these pictures are that. Also, since A is 1, A also controls whether we vertically stretch or we vertically compress. Do I have that going on in this? No, because A is 1, that means we have no vertical stretching and no vertical compressing. Because in order to stretch, you got to be bigger than 1. And 1 is not bigger than 1. In order to compress, you got to be less than 1. And 1 is not less than 1. So all these graphs are okay because they're not very wide and they're not very thin. Okay? So it looks like we're going to have to rely on what H and K are doing to tell us which graph to look at. So let's talk about H. Am I going to move left or right? You're going to move left. Because here it is. You're going to move left how far? 2. Remember, when you look at the H in the equation, it's the opposite of what you're thinking. So a positive 2, normally we would say, yes, let's move right. But it's the opposite. So instead of moving right, you're really going to move left. So I need any graph that looks like it has moved left 2. Which ones am I going to throw out now? C, definitely, because we moved to the right 2. So that's gone. Anybody else? And A. A definitely moved to the right 2. So A is now gone. That's a 50-50 shot. One graph moved up, one graph moved down. So what does K tell us up here? So where are we going? Down. How far? 3. Because that's this guy. So which graph moved down 3? Now you know the answer. Because this graph over here, D, moved up 3. So that was from 6.4. No, 6.5. Sorry. Down here, this part is from the 6.5. Sorry, 6.6. Gosh. This part is 6.5. This part is 6.6. So it wants to know what's the vertex. Cool. Our equation is in vertex form. Plus 2 squared minus 3. Remember, when you're in vertex form, this is the easiest to do. Because in vertex form, it is telling you the vertex. You just got to remember, for the H value, you're going to give me the opposite. For the K value, you're going to keep it. So what's the vertex? -2, -3. Because your H value is right here. What's the opposite of a positive 2? -2. Your K value is right here, and I told you to keep it. What's the vertex formula? Looks like this. That is your vertex formula, which is what this equation is set in. And last but not least, they want you to find the axis of symmetry. That's easy. Even though I may not have mentioned this in class, the axis of symmetry, whatever H is, it's the x part to the vertex. So our axis of symmetry is x equals -2. And they want it as an equation. So you have to put the x equals -2. Okay? Because you come up here, remember, this is your H value. And that's the K value. Okay? Yep. And your vertex is right over here. So this question mixed a little bit of 6.5 and 6.6 together. All right, jumping to the next guy. We're almost there, guys. Almost. So it wants you to find the vertex. It's in standard form. Well, that's not hard to do. So remember, in standard form, how do we find the x value? There's a formula I gave you. You remember what that formula was? Yes, it's something about b, but it's not b. It's not b minus. It's not that. What was that formula? Something over something. Negative b over 2a. And what was this called? This is the x, but what was this called? This formula had a specific name. I abbreviated the name. My abbreviation was AOS. What did that abbreviation stand for? That's the axis of symmetry. You use the axis of symmetry when you're trying to find the x value of the vertex. So let's plug in. Who is your b value up here? And what's the opposite of a negative 2? So your top value is 2. Because the opposite of a negative 2 is a positive 2. Who is your a value? Okay. So what's 2 times 5? 10. And 2 over 10 reduces to what? 1/5. Now you know the x value of the vertex. How do you find y? Plug it in. Yeah. Once you know x, all we're going to do is take this value right here, and we're going to come up here and we're going to plug into each one of these x's to figure out the y value. Plug and chug. So this is why we also have our calculators to help us out. So plugging in, we've got 5, and then I got 1/5 that I need to squared, minus 2 times 1/5, minus 4. So you use your handy dandy calculator. What is 1/5 squared? 1 over 25. And what is 5 times 1 over 25? 1 over 5. Good. 1/5. What's 2 times 1/5? And then all we're going to do is subtract 4. So down here, all you have to do now is take 1/5 minus 2/5 minus 4. And that will be the y value. Yes. So what do we get when we take 1/5 minus 2/5 minus 4? Say it again. Not mixed. We want it improper. Yeah, negative 21 over 5. There's your y value. And now you know your answer. You can use your calculator and put all this in one fell swoop. If we go over here to our calculator, let's do that real quick. It's 5, parenthesis, we need to put our fraction in, alpha y equals 1 over 5, close the parenthesis, and that is squared, right? Minus 2, parenthesis, alpha y equals, because we're putting in a fraction, 1 over 5, and then minus 4. Hit enter. They get 21 over 5. I would, so that way the calculator knows that this is what needs to be squared. Okay? The way that I wrote it down in my paper looks exactly like the way I put it in my calculator. Okay? I don't teach fractions by hand because we have our calculators. If your professor is making you do it by hand, then they're not utilizing a very important tool that you have at their discretion. You know, if you've got a tool that can help you with fractions, use it. Okay? Yeah. All right. So, another application. This one is coming from 6.6. So it says an arrow is fired into the air with an initial velocity of 110 feet per second. The height in feet of the arrow, t seconds after it was shot in the air, is given by this formula. So h of t equals negative 16t squared plus 110t. So find the maximum height of the arrow rounded to 2 decimal places. What are you looking for? The height. But how are we going to find it? What specific idea are you going to have to use? There's one word in here that should be blaring in your minds. Say it again. You're looking for the vertex. Exactly. What set that off? What word in here sends a signal to your mind saying, please find the vertex? There's one word. Maximum. When you see the words maximum or minimum, in your mind should be shooting off, find the vertex. That's what you should be thinking. And we're going to repeat the same thing that we just did a moment ago. We're going to find the axis of symmetry. We're going to take that answer and we're going to plug it in. Okay? So, we're going to run x equals the opposite of b over 2a. So looking at our equation right here, who is b? 110. So what's the opposite of a positive 110? Negative 110. Divided by 2 times, who is your a? Negative 16. So, negative 110 divided by, what is 2 times negative 16? Negative 32. And the cool thing is since we're allowed to round, we don't have to worry about keeping this as a fraction. Okay? So, negative 110 over negative 32 gives us what? Positive 110 over 32, but again, we can take it down in our calculator. Take 110 divided by 32. What do you get? What is 110 divided by 32? 3.4375? So that right there, I put x up here, but it's really t. So in 3.4375 seconds, the arrow will reach its maximum. But that's not what we want. We want to know what is the height. So we have to take this number, we got to plug it back in. Yep, plug it into t. So you're going to have negative 16 times 3.4375 squared plus 110 times 3.47 or 4375. All right. So again, just go into your calculator, plug this in the way you see it, and we can round our answer. Okay, we don't have to keep it exact. So your answer, it says round to the nearest whole. Although I don't know why it says dollar over there. That's weird because this is not money. So round to the nearest whole number. And that will tell us what H is. What'd you get? Well, like we just plug it in. Negative 16, parenthesis, was it 3? No. 3.434375, and that is squared, plus 110, 3.4375. Isn't that the way that we have it written on our paper? That's the way that we put it in our calculator. We hit enter. How high was the error? Rounded to the nearest whole. 189. 189 feet in the air. And it takes 3.4375 seconds to get there. So, 189 feet. Cool beans? Last one. We did it. Yay. In only 3 hours. All right, so the last question, this is coming from 5.6. So you're going to jump back into chapter 5, and it's all about complex numbers. Okay? So we want to actually perform the operation, and then we want to write it in standard form, which means that it needs to look like the A plus BI. Okay? This is a lot like what we just did with the rationalizing problem. We need to get rid of the I in the denominator because it's a radical. Again, some Joe Schmo says, I don't like radicals in the denominator. So we got to fix it. So how am I going to get rid of this 7 minus 6i? Again, this is a lot like what we did with the rationalizing problem that we had earlier. Yes. Multiply by the complex conjugate, which is 7 plus 6i. So in the denominator, since they're conjugates, do I have to really do all the FOIL? No. What do I got to do? Just Florida the bad boy. First and last. Because we already know the middle term is going to cancel out. So what is 7 times 7? 49. What is negative 6i times positive 6i? Negative 36i squared. And now if you remember back in that video that I made on complex, I squared really represents what? A negative 1. So anytime you have an I squared, I need you to go back in and change it to a negative 1. So this really actually becomes 36 times a negative 1, which really what's in the bottom then? 49, not minus anymore. It's going to become a plus 36. Because, well, if you want, you can think of it as a negative 36. A negative 36 times a negative 1, because that's what I squared is a positive 36. So what is 49 plus 36? 80 what? 85. So there's your real denominator. Now we just got to go mess around with the numerator. All right. So up here in the numerator, we actually do have to do the full FOIL. First, outer, inner, last. Because these are not conjugates of each other, nor are they complex conjugates of each other. So what is 1 times 7? So there's your first. What's 1 times 6i? There's your outer. What's negative 5i times 7? There's your inner. And what's negative 5i times 6i? Negative 30 what? I squared. And again, what do we know about I squareds? They become a negative 1. So this is really like a negative 30 times a negative 1. So on top, we have 7 plus 6i minus 35i. What's a negative 30 and a negative 1? Positive 30. So now all you do to clean up the numerator is put like terms together. So who's getting together up there? The 6i and the 30 and the negative 35i. So what is 6i minus 35i? Negative 29i. And who else is getting together? The 7 and the 30. Bless you. So what is 7 plus 30? 37. Now to get the answer, you need to separate them into their two fractions and do any reducing that's possible. Okay? No plus or minus. There's only a minus this time. So we separated into two answers, which is 37 over 85 minus 29 over 85i. That's what they call standard form, because this represents A, the 37 over 85. This represents the B, 29 over 85. Answer. Right here. What's a negative 30 times a negative 1? Positive 30, because I squareds are negative 1. So the last question, just to make sure, the 37 over 85, does that reduce? So you just check that in your calculator. And then you check the 29 over the 85. Does that reduce? If it does, reduce those fractions down. If it doesn't, then this is the final answer to the final review for your final exam. Finally, we're done. Okay? Anytime. Whew!